Okay, this video is going to talk about a couple things, mostly on law of signs. And law of signs is a way to work for finding missing parts of oblique triangles. There are triangles that are not right triangles. So far we've been dealing with right triangles where we have sine, cosine, tangent. We know what those ratios mean. But now we're going to start dealing with triangles that don't have right angles necessarily. And this one starts off with the idea of area of a triangle, and you're used to base times height divided by 2 being an area of a triangle. Now I kind of talked about this already, but if I have a picture it looks like this. And a few things we have to understand. Little a is opposite big A, little b is opposite big B. The capital letters are angles, the little letters are the sides opposite those angles. That's important. So if I look at this and it says B sine A, B sine A is going to give me this height right there. That's the height of the triangle. Okay, if you put an H here, write this out, and just do sine, you'll get that height over B. And if I cross multiply, I'll end up with H is equal to B sine A. So that's what's happening. That's my height. So if I take that times my base, C is this entire length, that's my base, C times B sine A all divided by 2 will give me the area of that triangle. In more general terms, if I take AB, which are two sides, times sine of the angle between those two sides, divide it all by 2. You have to remember, close off this angle in parentheses, and divide it by 2. That will give me the area of a triangle. So an example here, here's a triangle, 45 feet, 51 feet, the included angle. That means the angle between is 32. So 45, 51 sine 32 divided by 2 should give you approximately 680 square feet. Now I'm going to go fairly quick here, but remember you can pause this. So when I get pictures drawn and steps drawn, you might want to pause it, write out things. I'm going to hold this video to hopefully 15 minutes. So law of signs, I write it like this. A lot of times people do it with the reciprocals. It does not matter. I'm just going to traditionally do this. Capital A is angle, little a side. So this is saying the ratio of the sine of this angle to its side opposite equals the ratio of the sine B to its side opposite, ratio of sine C over its side opposite. So before I even discuss anything, I'm just going to take one and solve it. So get in here where I want. So looking down here, here's an example. Sine 32 over 14 equals sine 64 over little b. I cross multiply. I divide by sine 32. And again, on your calculators, make sure you close these things off with parentheses, and that should give you approximately 23.75. I would grab your calculator right now and practice that, see if it works. Next one, I have sine 32 over 54 equals sine C over 75. Again, I'm cross multiplying, but on this one, I have sine of C. So the best I can do at the moment is get sine of C by itself, but I want C. So to undo the sine, I have to do sine inverse. So I'm going to do sine inverse of each side. That will give me what C is. C should be this. Again, now typically, you know me by now, I simplified this and put that number in there. Typically, I'm not going to do that. I'm just going to take this number, put it all in at once, or this expression, put it all in at once, and get right to the 47.39. So again, practice that, make sure I'm right. So I made these numbers up. The theme is to cross multiply and solve. So you're always going to start cross multiplying and solving. So we're going to apply it to a triangle. So here's a triangle. Now this is important. I have to have a side opposite an angle. This method is not going to work if I don't have at least one side opposite an angle. In this case, 27 is opposite 32, so they're going to go together. And B, which I don't know, angle B is opposite 45. So that's what I have written out here. And here's my formula. And I'm going to, don't look at that, look at this. Sine 32 is 27. So sine of 32 over 27 equals sine of B over 45. That's what I have articulated here. Multiply both sides, cross multiply. I'll get 45 sine 32 equals 27 sine B. Divide by the 27. So I'm condensing my steps. This all works out to be 0.88 approximately. And if I do sine inverse of that, I get 61.64. Now, again, I'm a big advocate of doing it right here. That number might change a little bit, but I'm giving you the motions. And the whole point of this is that you come to class next, we can dive into this. So if B is around 61.6 degrees, and this is 32 degrees, then 180 minus those two will give me that. So that's where the 86.36 is coming from. So now I have this angle and that side opposite. I need this side. I have the angle opposite, so I'm going to use law of sines again. That's what I have written out here. Back this back down. Sine 32 over 27 equals sine 86.36 over c. That's what I have written. Cross multiply, divide by sine 32, punch it all in. Remember, again, parentheses around these. You should get around 50.85 feet. We now know all the missing angles and sides. So that's how law of sines operates. You're either finding a missing side or you're finding a missing angle. Now I would pause this, scroll, go back in time, look at your notes, try that again. Here's an example when it cannot be used. Here, this is just like my area one, right? I have this side, and this included angle. I can't use law of sines. I have to have one angle and one side that is opposite it. If I don't have that, I'm going to go in circles. It's not going to work. Okay? Here's another example. This one will work. 23 degrees, 124 degrees, that's obtuse. I don't have an angle written down here, but we have the power to figure it out because this plus this subtracted from 180 should be 33 degrees. That's what I have written there. So I can go sine 33 is to 37 as sine 23 is to A, or sine 124 is to C. And that's the two ratios I have written here. You cross multiply and solve. Do it and see if you get these numbers. Okay, not that big of a deal. Sometimes you'll be presented with a triangle or dimensions of a triangle that really does not exist. Now, you have to be careful here. Just because on some of these, I'm going to draw the picture and it is what it is. I'm going to say that's what it looks like. But sometimes you're going to get problems where they tell you this side is opposite 30 degrees. You have 100 here. Is it a triangle? So if I go sine 30 is to 22, sine B, this would be the B, is to 100, and I start solving that, get this figured out here. All right, the height of a triangle must be 50, because we already learned that. This side here of this height, that's the 30, 60, 90. If that's 100, this has to be 50. Well, can this be 22? Can that be 22? If this is 50 and I'm calling that 22, is there any way that can work? No. 22 is shorter than 50. This side's up here swinging. It's not touching the other side. This doesn't form a triangle. So this is not a triangle. You would get an error if you try actually solving this. You would cross multiply, do sine inverse of that, and it'll give you an error. If it's giving you an error, that means something's not working. The ambiguous case. All right. So this is a tougher one. We need a scheme for drawing these triangles. Bollington method. All right, I always put the known angle with a known opposite side in the lower left corner like this. So if I give you an angle on the side, that's what I do. Then hopefully I know this angle on that side. That's what I'm going to try and get next. And this is just a guide. This is to get you started. You do something along these lines. And what you know here, what you don't know there. And it's ambiguous. That means we could actually have two different triangles where this works. And we'll get into that as we progress. You can read this, pause this, read this. I'm not going to read it all. So an example, C is 32 degrees, side C is 14, side B is 25. Now we need to draw a triangle. So I put 32, I put 14, I put the 25. All right? That's just what I always do to start with. Again, it's not drawn to scale. This is just a triangle. I'm going to use law of sines to find B. So sine 32 over 14 equals sine B over 25. That's what I have here. You can cross multiply. You get sine B by itself, however you're doing it. This one, I'm just multiplying both sides by 25. I have to do sine inverse. I get B is 71.08. So I would put 71.08 degrees in. And then take 180 minus these two, and I get 76.92. Then I can use law of sines again here. Always use the given information. That's why I'm always using sine 32 and 14 here. You always use the given information and solve for A, and I get 25.73. Okay, easy squeezy. But now, this could all be wrong, because my triangle could really look like that. I'm going to scroll back up. I know it's 32 degrees. I know it's 25. I know it's 14. I could have drawn this picture. If I draw this picture, you'll notice that this is an obtuse angle. So when I go through the same motions, when I go through solving for angle B, here I get 71.08 for that angle. Well, it could actually be 180 minus that, and that would be 108.92. So that angle right there could be 108.92. 108.92 plus 32, take that away from 180. That would give me a different angle there. In this case, angle A would be 39.08. And if I set up the ratio to find the missing side, the other missing side is 16.65. So we have two different triangles that could be drawn from the given information. That's why it's ambiguous. That's the tough case with the law of sines. That's what makes it difficult. So here I have case 1 written out and case 2. Okay, this is probably important. When you find the first missing angle, remember it could be acute or obtuse. So you're going to do both cases. Now on this one, 40 degrees, 60 degrees, 82, this is the case where it's acute. When you go through the process, you might want to pause it. So angle C, this is keeping angle C that, this is keeping angle C 180 minus that, because the point is, punch this in your calculator. Sine of this, sine of that, you're going to get the same numbers. Okay, so the missing other missing angle, in this case 78.6, 21.4, plug those in, and I can get the missing side. So I get two different triangles. So once you find the first missing angle, do both cases at the same time. Neatness counts. Yes, I can't believe I just said that myself. Okay, so yeah, you have to try to be neat, keep things going. All right. Is there two cases? Is there always two cases? No. So here's a case where I'm going to give you an obtuse angle, or you only have the angle so shallow if you make this obtuse it won't work. So in this case, this is 21, that's 150, that's 23. We find the missing side, this is 3.15 degrees. 180 minus that is 176.85 degrees. So if I do that, 180 minus 21 minus 3.15, that's the first case. Here's the second case. 180 minus 21 minus 176.85. That should have an equals right there. That gives me a negative 17.85. Makes no sense. So there's only one case in this one. The other time you'll only have one case is if the given angle that they give you to begin with is obtuse. And that takes me to the end of this video. And watch it. And I'm going to go through all this again, but it's a lot easier if you watch it ahead of time and get at least the idea what the law of sines is. Okay? All right.